We begin a large study now of algebraic expressions and multiplying and dividing those and adding and subtracting polynomials, foiling, if you've ever heard that in your past. But one of the hardest things is the study of exponents and the rules for exponents. So this segment, or two, is going to help you to understand a value, an expression, that is a base raised to an exponential power or an exponent, and help you understand what this means. So 5 to the second power means take the base 5 and multiply it times itself 2 times to get a value of 25. Essentially, this is shorthand. It keeps people from having to write down 5 times 5 and then stating that it is 25. Big thing, I want you to understand that the base is the large number and the exponent is the small number that is raised high. So in this negative 2 to the fourth power, the base is a negative 2. The sign and all, because it's in parentheses. And the exponent for this one is that positive 4 is the exponent. Now what does it mean? It means take a negative 2 times a negative 2 times a negative 2 times a negative 2 4 times, and when you do that you get a positive 16. Okay, let's continue now. Next, your directions will say evaluate this exponential expression, which I've been doing with you anyway. So 5 to the second power, when I say evaluate, I want you to find, I often will highlight these 4 letters. It's supposed to be the word value without the E on it. Find the value. When I say evaluate, I want to know that this is equal to 25. Be careful. This one, a negative 5 squared, means that I want you to give me the opposite. So kind of ignore that that's there. I want you to give me the opposite of 5 squared. Well, 5 squared is 25, and that was the erase symbol, so I have to be careful. So I have to put the symbol on afterwards. So this right here is 25, and then I want the opposite of that. So I will ask you to tell me that 5 squared is 25, and that a negative 5 squared is a negative 25. However, if I were to put the negative 5 in parentheses, now I really do mean a negative times a negative is a positive. And I want you to know that even your calculator, when you type in 5 squared, no problem. When you type in, if you tell it to put in the parentheses, oops, didn't mean to. So 5 squared, no problem. If you tell it, I want a negative 5 squared, no problem, but it knows that a negative 5 squared is a negative 25. So you can use your calculator too. Okay, let's continue on. If I have a negative 2 to the third power and I ask you to evaluate that, I just want a negative 2 times a negative 2 times a negative 2. Use your calculator if you need to. If not, this negative times a negative is a positive 4. Then I multiply it by the negative 2 and I get a negative 8. Up to you. If I give you a fraction, no big deal, but I would like you to deal with the fraction. So it's in parentheses. This means a negative 1/6 times a negative 1/6. A negative times a negative is a positive. You don't need to write a plus sign. 1 times 1 in the numerator is 1. 6 times 6 is 36 in the denominator. All done. Finally, if I put a number in front of a base that is squared, order of operations says that you must take this base and square it first and get 9. So 3 to the second power is 9, and then multiply that by a negative 2 and get a negative 18. Okay, I'm going to turn the page. Let's talk about multiplying bases. Multiply. Okay, there we go. So now I'm going to go more with letters. So if I had x to the third times x to the fourth, this is what x to the third means. It means x times x times x. I'm going to put parentheses around it. X to the fourth means x times x times x times x. But if you put all of this back together in shorthand form, you'd have a base of x, and 7 would be your exponent because there's 7 of those x's. So the shortcut when you're multiplying is to add those exponents. It can get confusing. You got to maybe make a little note card for yourself. So if I have a times a to the 7th, what's the exponent on this a? If it's not written, it's a 1. So a times a to the 7th is a to the 8th power. Let's expand this a little bit. Let's say I have x squared times y to the 3rd and x to the 4th times y to the 6th. I'm going to move these around because these are all just multiplication symbols, and multiplication can be done in any order. Do I need to? Not necessarily, but I want you to see the x to the 2nd and the x to the 4th side by side. Because their bases are alike, I get to add their exponents and make it x to the 6th. The y to the 3rd, I want you to see it next to the y to the 6th because their bases are alike. I want you to call that y to the 9th. So the answer to this problem is x to the 6th, y to the 9th, because when I multiply the x's together, I add their exponents, and when I multiply the y's together, I add their exponents. Let's go on and do a few more. So let's go negative 2 z to the 4th power times a negative 2 z to the 7th power. So same here. The numbers negative 2 times negative 2 can be multiplied together to be a positive 4. And the z to the 4th and the z to the 7th can be multiplied together because their bases are alike. But when you multiply, 4 plus 7 is 11. Let's turn the page. So we have now a negative 3 to the 7th power and a negative 3 to the 2nd power. So they don't have to be just letters, and you don't have to get a calculator out to do this. These bases are alike. They're both negative 3's. So I can add the 7 and the 2 and get a 9. So I would have a negative 3 to the 9th power to simplify this. Finally, in our multiplication, so this has been the study of multiplication, let's go ahead and multiply these together. But I want you to know that what's in front of this x squared is the number a negative 1. So the 12 will get multiplied by a negative 1 and will become a negative 12. The x to the 5th times x to the 2nd will become x to the 7th. So I'll have a negative 12 x to the 7th power. We're going to come back and do 2 or 3 more properties in our next segment. They would be raising a power to a power, then we'll do some dividing, and then we'll talk about 0 as an exponent.